Welcome to today's presentation, Counting Collections, Building Early Number Sense. This presentation is being brought to you by Catherine Vittorio and Melanie Janzen. We are math coordinators for the San Bernardino County Superintendent of Schools. There are resources for this presentation that you can access by typing in the bit.ly into your server. Please be aware that the bit.ly is case sensitive. It is very important that we focus on supporting the development of number sense. Number sense is a key foundational skill that determines how well students will do in the area of mathematics. Number sense is not taught, but rather it is developed as a result of experiences and connections that students make as they develop as mathematical thinkers. Number sense can and should be developed at home, at school, and in our day-to-day activities in life. From time to time, our students will be faced with collections, quantities of items that come together in piles or scoops, or maybe they're toys or snacks. But our students see groups of things. And it is important that we assist them in developing the skills to make sense of the quantities of items in front of them, that we help them develop the skills necessary to group, to count, to make sense of large quantities and their relationships to other items. So throughout this presentation, we're going to provide opportunities for you to make the connection of how this activity can be extended and supported at home. Counting collections, much like their title suggests, is a structured opportunity for a student or a child to count a collection of items. This item can be something that they want to count, that can be presented to them in a collection. Perhaps this item can be small toys that they have collected. I know my children have collected Legos over the years, and they have counted them in various ways, in addition to small items such as buttons or coins or bottle caps. We've collected many things over the years. And counting collections is a great activity to help develop our students' concepts of not only counting, but an understanding of quantity and the foundational skills for understanding the base 10 number system, which we operate in every day. Why is counting important? Well, this is an important skill and understanding that make up counting are developed through many opportunities to count. It's not just something that happens. We want to present the opportunities to our students so they develop the necessary and flexible skills that will support them as they continue in their mathematics studies. Some of the important concepts that children develop include naming numbers. So, what do I say when I see 3 green squares on a table? I call that group 3. So it is important that I not only understand the quantity, but also the name of that group. It's important for sequencing numbers that I have an ability to say the numbers in the order that they belong in, that I have that stable order, an ability to say numbers as they are in sequence 1, 2, 3, 4, 5, and so on. It also develops the opportunity for one-to-one correspondence so that when I am counting a group, a collection of items, that I name an item once and only once, and so that I don't get confused. It's important to provide students the opportunity to develop and understand cardinality, that the last number in a group, 1, 2, 3, 4, 5, names that total amount of objects in that group. It is important for relative size and our understanding of which group is bigger. I counted 6 in this group, and I counted 4 in this group. Which group is bigger? It also plays an important role in our understanding and development of the base 10 structure. How do these numbers, written and verbal, go together? This is a group of 10. 10 ones can also be represented by 1 10 in the tens place. So as our students expand their number system understanding and their understanding of place value, base 10 structure is very important. And also the understanding and having a foundational skill of efficiency and accuracy when counting. How can I group objects to count and record them more efficiently? How can I represent and communicate this in words, numbers, and drawings? So, as you will see today, through a simple activity called counting collections, we can support our students as they develop as mathematical thinkers, having the flexibility and fluency in their number system sense. So, we want to develop our counters and we want to develop their skills over time. So young students, are working to coordinate three very important aspects of numbers during counting collections. They see a group of objects, as you see those blue dots, and they can count those, and they understand that that is a group of 12 objects. But they also can represent that with a numerical representation of a 1 and a 2 beside each other, representing 12. We also see the written form of the number 12, TWELVE. So our students are working on all three of these aspects as they count their collections. So where do we begin? Well, how many buttons do we have here on the right side of our screen? We see a group of buttons. Many times with my students, I'll begin with some very simple questions of what do you notice? And I use that simple question of what do you notice to get students engaged and to get them to be active thinkers about what is in front of them. Students may say, I see a big blue button in the middle. I see two square red buttons. I see that some buttons have 4 holes, and I see that some buttons have 2 holes. Others may say, I see that some buttons are in the shape of a circle, and some buttons are in the shape of a square. I might ask them, do you see any buttons in the shape of a triangle? I can engage the students in first exploring and making sense of their collection before they actually start the counting process. Then I might ask them how they would like to count their collection, and I let them explore. Some of my students may take these buttons and stack all the big ones one on top of the other. Some also may choose to sort them by color and count them in those kind of groups. Some may put them into groups of 5 and count 5, 10, 15, 20. Some may decide that it's more efficient to put them into groups of 10 and count 10, 20, 30, and so forth. What is most important is that my students have the opportunity to develop those skills as they are ready through my support of just asking them some guiding questions. I interject, but I don't dominate. I might ask them a question, but I do not force them to do something in the beginning that they may not developmentally be ready for. I love when my students use 10 frames, and we'll get into that, to count because it's a very efficient way for them to see the quantity of 10, organize the quantity of 10, and count by the quantity of 10. But I don't want to suggest that to a student who is still making sense of stable number order, counting 1, 2, 3, 4, as opposed to 1, 3, 5, 6, 7, 9. That order is not stable. So we want to present them the opportunity and let them develop as they are ready. So some easy collection ideas include buttons, old puzzle pieces. I know I've lost jigsaw puzzle pieces, and then I've just turned that into a collection. Playing cards, perhaps that are incomplete decks, pattern blocks, some rocks, some plastic bottle caps just off of my water bottles I've just collected over time, maybe a bag of pennies or a cup of pennies, some Legos. I know my students have collected small little toys, and I've just had those go into collections, or some small erasers. I've even had some students turn their snack, like the goldfish we saw on the preceding slide, into a counting collection. But if we do use food, we want to be very conscientious to have it be for their hands only and at appropriate times. Well, how many items do I put in a collection? Well, I will say that varies depending on the age and developmental readiness of your child. So, if your student is a kindergartner, for example, I like beginning my collections with some items somewhere between maybe 10 and 15 at the beginning of the school year. But by the year, middle of the year, and by the end of the year, I love seeing their growth, and they can get into collections that are well over 100 items. For our first graders, we begin the year somewhere in the 50 range, maybe up to 100, depending on the counter and the student. And later, by the end of that year, we could have collections as large as 200. Remember, the most important part is to not have the collection be so far beyond the student's ability that frustration settles in and we become the one counting the collection. By second and third grade, it's very common for our collections to begin with somewhere between 100 and 150 objects. Students can organize those into ones and tens, and the collection will gradually increase in size. And as our learners proceed to the fourth, fifth, and even sixth grades, we know that we could have collections that go up to 300 or more items. We also start to look at collections a little differently. Maybe the collection is 12 boxes of 8 crayons. And how would our students organize and count those? And that's where we start seeing some of the other operations come into play. The one thing I would suggest, though, if we're doing this at home, is that we don't land on friendly numbers. And friendly numbers are numbers like 10, 15, 20. Try not to become predictable with our learners. Have the collection be 14 items, or have the collection be 24 items, or possibly 56 items. Try and stay away from those nice friendly numbers because our students will stop counting once they see and they make that assumption that every collection will be the same number. We like to keep it different for them. There are 5 basic principles of counting, and some of these go together more than others. And I just want to go over them briefly for you so that you have an idea when you're hearing and seeing your learners present in different ways, that you understand and can make connections that support the development. And as we talked about before, one of the principles is called stable order. And for us, that's basically an understanding that our students the list used to count the numbers is repeatable and it has an order. So 1, 2, 3, 4, 5. That's stable order. But we've all probably seen some of our kids go, I say, how many crackers do you have? And they go 1, 2, 14, 11. And they know and recognize numbers, but they're not putting them into a stable order. The other idea is called one-to-one correspondence, and that's where when we're counting items, possibly we're touching them or we're using a pointer and we're saying 1, 2, 3, and we move on from item to item, giving each item one count and only one count, that we don't double count, that we're able to recognize that we've counted that item. And then one of the concepts that's very important, especially for our TK, pre-K, and kindergarten students, is the idea of cardinality. And this is where the number of elements in each set or other grouping is named by the last number that we say. If I have 7 marbles on my mat and I'm counting them, that I recognize when I get to the number 7, and that's the last marble, that the name for that set is 7 marbles. There are 7 there. Sometimes what we see is students who are struggling with recognizing that and being able to hold on to those ideas, they have to constantly recount the group of numbers. So we want to just support that by naming that number and how many are in the set. We also have the idea of abstractions, and the items of each set can vary. So I might be counting red checkers, and then I mix that up and I add to my group of red checkers maybe 4 marbles. That set is still and can be all counted together as a total in the set. So the abstraction means I don't just count one item if they're all a part of a set. I don't have to break them apart by the way they look or some of their other attributes. And order of relevance, items can be counted from left to right, right to left. We have students, what I call popcorn count, that go 1, 2, 3, 4, 5. And I struggle to keep track of where they're going. And they absolutely have got every item, and they get to 7, and there are 7 items. They have a flexibility of not only counting in one direction. So as these are the principles, you will start to see, and I have a brief video that I'm going to show you, what these look like when we are actually using them.
There are 5 counting principles, 3 of which are absolutely essential. The first 2 go hand in hand. The first is stable order. That means that students need to know their number names in order. 1, 2, 3, 4, 5, 6, 7, 8, and so on. You tie stable order with one-to-one correspondence, which means you give each object one count and only one count, like this: 1, 2, 3, 4, 5, 6. Now, the third counting principle is cardinality, which indicates how many are in this set. When I counted this set, 1, 2, 3, 4, 5, 6, the last number I said was 6, which indicates that there are 6 objects in this set. Now, the other two counting principles are not essential, but efficient counters demonstrate these principles. The first is abstraction. Abstraction means that you can count any set of objects. So, for example, I could take out some of these motors, bring in some clips and a bear, and if I say that all of these are in the same set, I can count this as a set. For example, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 objects in this set. It does not matter that they're not all the same shape, color, or size. And then the fifth counting principle is order irrelevance. I can count objects from left to right. 1, 2, 3, 4, 5, 6, 7, 8. I can count objects from right to left. 1, 2, 3, 4, 5, 6, 7, 8. And I can really count objects in any order. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 objects in this set.
So what we saw in that video clip, it was a review. This video clip that I want to show you, this is a 4th grader, and this just shows an example. Leila is being presented with an opportunity to count some coins. And what I want you to do in this video clip is just to focus in on how she's making sense of this. We've all been presented with the need to count a couple of coins, or maybe we have some coins that we want to cash in before we had the days where the machine counted it for us. But listen to how Leila is making sense of the collection presented before her.
Mm-hmm. Mm-hmm. All right, wait, before you... So we want to figure out how many pennies are in that cup and what might be the value of it. Okay, so how would you go about figuring that out? What would you do?
Okay. So all out. It's a lot, right? I would just count one by one. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
Is that the best
15.
way to do it? Or what happens if you forget?
Then you'll have to start all over. But I have many different ways you can count.
Okay, let's see.
Okay, so you're just gonna find 5 of them. Or 2, whichever one. I'm just gonna go with 5 because it's faster. So you have a little group of 5 right here. You're gonna go 5, get another 5, it's 10.
So I see you're making stacks of 5.
Yes.
Okay.
15. 20.
So looking at the stacks that you've made so far, what estimate do you have about how many pennies there are in that pile?
In this whole pile?
Mm-hmm.
I don't know. I'd say about 500.
Okay.
Because this is huge,
It
okay?
is pretty huge.
So,
All right. Is there another way that you could group them that could be more efficient in trying to count all of those pennies?
at the same. Yep, you just make stacks of 10. 10, 20. It'll take you a while, but it'll be faster than just counting one by one.
Okay.
So 20.
So how many? So we've got 20 pennies so far.
And then
So how many is that you have?
this
Mhm.
is 30.
Okay. So can we hear you counting?
7, 8, 9, 10.
Okay. Keep going. So now you have, so you're counting up to 10 and then you're counting in groups of 10 once you have the stacks.
Yes. If the stacks were pre-made, it would be easier, but they're not
true.
pre-made. So now I have 40. I just grab a handful and I just count them off. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Then I stack them up nice and neat. And then, let's put them here.
So why did you put them like that instead of the other place?
What?
So now you have them 5 across instead of starting a new row. Why did you do that?
Because I wanted to know, once I get to, so now I know I have 50. So if I have another row, then I know I'm already at 100.
Oh, okay, I see.
So I'm just going to go 5. 5 groups of 10 is 50. So then I can just count by 50.
Okay.
How many? It depends on how many rows I have, though.
Mm-hmm.
So if I have 1 row, it's 50. 2, 100. There's 3. Then I have 250. That's kind of a lot, I know.
So looking at your stacks of pennies now and your first estimate of 500 pennies, do you still think that's a reasonable estimate looking at what you have so far?
Yeah.
Okay. And then how many is 500 pennies?
500 pennies? That's $5. And another way you guys can do it is you can group them up by how much a dollar is. So you can group 100 pennies, and that'll work even better. But it'll still take a while. Just group up 100 pennies, and then it'll count by hundreds.
Nice.
It'll be easier, but it won't be as fast. Either way, it's not going to be as fast with this huge pile.
All right. Thank you.
So what we saw in that video is an opportunity. That was a parent at home doing a counting collection with the child. And what Leila was able to present to us is an opportunity to see. She began by saying she was going to count 1 penny at a time. And quickly she ended up going to her reserves of some strategies and some groupings and that kind of thing. And that's very important. We also know that in these counting collections, as the students get older, so Leila being a 4th grader, we saw some more advanced skills, obviously, that we want to recognize that there's innovations and extensions to counting collections that can happen, where we gave, for example, in the collection of coins, a group of coins were given. We could also flip that. And perhaps we give her a card that says you need 289 of these pennies, and watch how that is constructed versus the counting and naming a collection. Here we're going to give you a quantity and ask you to construct the collection. A little bit different, but it also is a skill that we want to develop. We can ask our students about whether their collection is odd or even and have them defend that. How do you know it's odd or even? And what we would see there is that student of that fair share and equal groups and those kind of things. We can ask our students, how many 10s are in your collection or how many 1s? We heard Malanie doing that with Leila and asking her about how many 500 pennies is and making a connection to some of the learnings that she's already had, right? With money and that kind of thing. Estimating before we counting is valuable because it gives our students a sense and an understanding of quantity and relationships. I remember asking my 4-year-old nephew how many he had, and he thought he had 5,000, and it turns out he had about 32. So it's a very big difference when they're little. They know these big numbers. They've heard these numbers, million. Little kids love to say the word a million. They have a million of something. And then when they actually count it and they name that set, it just helps reinforce and gives them that understanding. Having them revisit that estimate from time to time as they're counting, just as we saw Leila do. She still was standing by her 500 pennies, but we know that the student might change, and that's okay. But have them defend why they're changing and let it be okay, because the closer they can get, that's also developing their sense and their understanding. We know that some additional innovations and extensions of counting collections can happen when we think about operations. I might count one collection and another collection, and then might be presented with the opportunity to figure out how many do I have altogether. Or I count one collection. Maybe I have 47 items in it, but I need 100 items. Well, how big would my other collection have to be? And now I'm working with an unknown total for that second collection. So when our students are working with those unknowns, that helps also develop and build that sense of their understanding and flexibility of how they see numbers. We know that our students will quickly in third grade, actually by the end of second grade, move into some concepts of multiplicative reasoning. And our students might be looking at things as groups of multiplication. We know that it's equal groups of something. And understanding that multiplication, we see in this picture, this is 6 groups of 6 buttons each. And our students being able to count and see and make a connection between the number of groups and the number of items in each group helps them understand. We can also encourage them to use skip counting. We know skip counting is directly related to their multiplication facts and understanding. So we see students starting in kindergarten counting by 5s and 10s, and quickly our students, once they learn to count by 2s, it doesn't take them much time to make the connection of counting by 20s. Well, I could apply the same concept in this picture, and I could count by 6. If I count by 6, I'm really skip counting my 6 multiplication facts. So these things help our students and aid them as they develop. I'm going to just present a few examples as we begin to wrap up our time together. This is an example of a kindergartner who was at home and presented with a collection of macaroni. These were large pieces of pasta, and the student was provided the opportunity to make sense of these first. And sometimes that might look like playing to us as parents and guardians, but really our students need to make sense of the size and the quantity. This student was asked to estimate how many pieces they thought they had. And then one of the things this student likes to do is put their collections into columns and rows. We're going to find that columns and rows are a way of really organizing equal groups. But this student's rows, because these items were rolling and not as stable as they wanted them to be, might have gotten a little messy. So as the leader of this, I might ask them how their collection and how the organization of their collection was helpful. And I know what his response was, is that he was able to count easier. And then my follow-up question was, what might you do different next time? Well, next time they wanted to put them in groups, but they didn't want them all to be connected the way they are and rolling, because they understood that that was making it a little less tidy than they wanted to. Well, that student came to that on their own. They recognized that there were a couple of rows that had more than each of the columns had the same number of items, but it appeared that it wasn't clear to them that they had one of those items left that wasn't in one of the groups. It was a 1. And so they were making that conjecture that next time what they would do a little different. In this collection, the student was presented with a baggie of beads. And oh, did they love the beads. They were so colorful. It was a small cup. And the student began by making sense of the beads, and there was recognizing that there were some stars and some crowns and some different things like that, and trying to see if all of the colors were represented by the different types. And so it's a little bit of that playing, and I always like to give my littles in my life an opportunity to make sense of it and connect with it before they have to count. Then this student was starting to put the items into groups. Now this is a second grader, and it began by putting them into groups of 10. But what quickly became a shift was just like we saw with Leila shifting her approach. We saw this student shift to making groups of 20. And then this student applied that their skill set of counting by twos and tens and started counting by 20s. So my follow-up question here was, how can the strategy of grouping be beneficial when you're counting something large? And this student was able to articulate, they were able to keep track of how many they had by counting in that and quickly being able to see that 3 groups of 20 was 60 and so forth. And so the student was able to communicate that. In this example, we see a combination of a tool being used, which is our 10 frame template. You see the 10 frames, those white and blue cards that are on the table, as well as a recording sheet. We do have access to recording sheets for you. They are on that link that we had, and I have the link at the end of this presentation again. But what this student did was took their quantity of their collection, put them into groups of 10, and then counted them that way. And then they were able to record through a visual representation how they counted. So I asked the student, how did using a tool such as your 10 frame, how was that helpful for you when counting such a big collection? And that student was able to say they had an ability to keep track of. And I thought that was very important. And I asked them, is there a different tool you might use next time? Well, this is a first grader, and so counting by tens was not a problem. But this student wanted to challenge himself to next time count by hundreds. And I asked him how he might do that, and he said he might get 10 white 10 frame cards and 10 blue 10 frame cards and make a big giant 100 10 frame. And I was like, wow, where will you put that? And he said, I'm going to have to work on the floor. And so I said, what if your collection doesn't have that many in it? And he goes, well, then I won't need all the cards. And so I thought that was very insightful of this student and the way that they were beginning to work. And again, this is just a student as they are developing. So we may have a first grader here, and we may have a first grader who's still counting collections that are in 20 and 30 items, and that's okay. We want to support them where they are in their development. So what I've included here on this card is some questions that you can ask your students, your children at home, as they're counting their collections. And so this is just a reference for you. It's always something to just kind of keep in mind of which collection has more, which had least. How did you count them? Why did you choose the tool that you were choosing? And so just asking your students some guiding questions, but try not to dominate their experience as they're counting. So we want to thank you for this opportunity to share, and we want to wish you well and tons of fun as you're collecting and counting your collections. Start simple, start slow to go fast. Your students will love it. They will help you become the best co-counters that we can have. This link at the bottom of this presentation does provide you with the resources. So we wish you well and look forward to next time.